Alrighty folks, I thought I would put together a little video so you guys can have something to study and to watch over and over and over again because you find equalities so interesting. First, we're going to start with one-step equalities, which essentially just means you're going to be doing one inverse operation to solve for the unknown variable. So for this one, we're trying to find m. M is unknown right now, but we can use a one-step inverse operation to figure out what m is. Now, of course, we are trying to find m. We're trying to end up with it by itself equaling something. M equals something will tell us what m is. So here's how we do that. Right now it's m plus 3.7. That plus 3.7, we got to get rid of that. He's clinging on to m. We want m by itself. So the way to get rid of positive or plus 3.7 is to use the inverse of that. Inverse means opposite. Opposite of addition or positive, of course, is negative. Negative 3.7. Now we also have to remember what this equal sign means. It means that everything on the left side of this equation is equal to everything on the right side of the equation. So if I am subtracting 3.7 from this side, to maintain this equal, I have to go minus 3.7 over there as well. So now positive 3.7 and negative 3.7, those cancel out. M drops down, equal sign drops down. Now using, excuse me, using our integer rules, okay, 2.4 take away 3.7. Well, 3.7 is a greater value than 2.4, so I know my answer is going to be negative, okay? And the difference between 2.4 and 3.7 is 1.3. So now we figured out what m is. M is equal to negative 1.3, and we always circle our answers, of course. Okay, let's do another example. We've got 0. Oops, sorry. 0 is equal to n plus negative 38. Well, what's the inverse of negative 38? That would be positive 38. And of course, I have to do it on both sides so it's fair. So it is equal. These cancel. N drops down. Equal sign drops down. 0 plus 38 is 38. There you have it. Easy peasy. Okay, let's beef it up a little bit. Make it a bit more challenging. I'm looking at the wrong one here. There we go. It's hard to write and film at the same time. So we've got n subtract negative 10 is equal to 20. Well, we have to think back to grade 7 math in our integer rules. And one of those integer rules tells us that subtracting a negative number is the same as adding a positive. So before we do any inverse operation or anything, let's just go ahead and do that. So subtracting a negative is the same as adding a positive. And I don't have to go positive 10. We assume it's positive 10. It'd be redundant to write down positive, so I won't do that. Equal 20 drops down. Cool. So now I'm going to use one step to solve for this missing variable. Okay, I want n by itself. Right now it's being tied down with plus 10 or positive 10. The inverse of that is negative 10. I'll do that on both sides. These cancel. N drops. Equal sign drops. 20 take away 10 is 10. N, oops, is 10. Done. Okay, we only have 2 more examples, don't worry. Excuse me. Trying to find W. Got to solve for it, but now I'm working with fractions. Okay, yuck. This makes it a bit more challenging. Notice my ugly scratching. This is why you should always use a pencil. Whoops. So when we're working with fractions, you can turn these into decimals, but I urge you not to. Often you'll be working with fractions that don't turn into a nice, clean decimal. It'll often be a repeating decimal, which means you'll have to round, which means your final answer for W won't be exact. We want to be precise and we want to be exact. We want to figure out what W is. So keep these in fractions. Just make it easier on yourself. Keep in fractions, okay? So I got to get W by itself. I got negative 3.4, tying it down. What's the inverse of negative 3.4? The inverse or the opposite? That would be positive 3.4. And you know what, just to make this easy on me, I'm going to put brackets around it just to show that these are together. This is one term, okay? I'll do the same over here. So it's equal, so it's fair. Adding 3.4 over here, I have to do it on this side of the equal sign as well. Cool. These cancel. W drops. Equal sign drops. 1.2 is still there. Or sorry, not 1 over 2, pardon me. And now it's being added with 3/4. Before I can actually add these fractions, I have to find the common denominator. I know that 2 has 4 as its multiple. So I'll times this whole fraction by 2. I'll leave 3/4 as itself. 1 times 2 is 2. 2 times 2 is 4. Plus 3/4. W is equal to 5/4. Cool. There's my final answer. And if, of course, you wanted to put it in a mixed number, 5 has 4 go into it one whole time. Sorry, I'm running out of space here. 4 goes into 5 one whole time, and there'd be 1/4 left over. Cool. So fractions, we're doing one-step equations with them. No problem. We just have to think back to grade 7. How do we add fractions? Of course, you have to have that common denominator. All right, lastly, this one's a little bit tricky. So I'm gonna break down how to do it, what you need to know on how to do it, and then after that, why this little trick works, which is important. You always wanna have understanding of what the heck you're doing with math. Don't just remember all the tricks, you have to remember why the tricks work. Cool. So of course, I'm trying to find k. I want to figure out what k is equal to. I want k by itself. So before I can do that, I got to get rid of this -20, tying it down. Well, what's the inverse of -20? +20. Do it on both sides. Equal. Fair. Cool. Cancel. -7 plus 20. Remember back to our integer rules, grade 7. Okay. 20 is the greater value, so I know my answer is going to be positive. I won't write the positive because it's redundant. The difference between 20 and 7 is 13. Now here is the tricky part. Let's fix that a little bit. Here's the tricky part. The common mistake that happens is that k drops down. That's correct. K should drop down. We want it down there. But we also have to remember that this negative is assigned to it. This is negative k. Subtract k, yes, but it's also negative k. So the negative sign has to come down with it. I can't circle this yet. The answer isn't what negative k is. I don't want negative k. I want positive k. So now we've got kind of an issue here. How do I figure out what k is? How do I get there? Here's the trick. And for all intents and purposes, when you're doing these questions, this is the trick you got to know to be able to do this. You write down both terms, so negative k, 13, and you just flip where the negative sign is. So the negative sign was with the k before. I didn't want that. Whew, I'm going to flip it over here. Negative 13 is equal to k. That's the correct answer. So when you end up with a negative variable equaling some number, you just flip that negative sign over to the other side. Okay? It works. This is the correct answer. Now you might be wondering, I hope you're wondering, why? Why does this work? Well, whenever we have a negative value, you know what, I'm gonna just rewrite this over here, just so we have a bit more space. So 13 is equal to negative k. Cool. Whenever we have a negative value, and it can be negative k, it can be a -1, it can be a -1,000,000, whatever, we can also rewrite this as -1 times whatever that value was. So in this case, it was k. So -1 times k. Every single negative number is like this. We just don't write it like this because it's redundant. We don't want to have to write brackets every time. We don't want to have to write -1 timesing all that every time. So we just merely write the negative in front of it. But in reality, this is what negative numbers are. The number times by that -1. So how do I go from 13 is equal to negative k? Here's how you do it. The long way, and this is to understand it. I've got k times -1, and this -1 is stopping me from having just k. So what's the inverse of times by -1? Well, the opposite or inverse of timesing, of course, is division. So I'm going to divide by -1. But we have to keep it fair, so I got to do the same thing over here. Divide by -1. Cool, these cancel. K drops. If I can write it down. Equal sign drops. Boy, my writing's getting worse as I do this. Okay, K and equal sign drops. 13 divided by -1. Well, there's an odd number of negatives in this operation here, so we know it's going to be negative, and 13 divided by 1, of course, is 13. Check it out. Boom. Negative 13 is equal to k, just like we had it over here. So, to save you from doing even more work and filling up your page, having you to use 2 Post-it notes if you're me, this is the trick. You have a value equal to a negative variable. Merely take that negative and whoosh, put it to the other side, just like I did here. You will have the correct answer. Just proved it. Okay. Now, one other thing I should note. This can happen. Let's say you've got negative 20 is equal to negative a. Sure, a is a good variable. Why not? Looks like 9. Pardon me. A. Okay, I don't want a negative variable. We said to get rid of that negative on the variable, I'm just going to put it over there. Okay. A is going to drop down. Cool. Equal sign is going to drop down. Cool. But now I'm taking this negative sign and putting it over here. Negative 20 is already negative. It does not remain negative. It's like negative 20 timesing this negative. Negative times negative equals a positive. Your answer is going to be positive 20. So there you have it. A whole bunch of stuff for one-step equations. And of course, we were dealing with addition and subtraction for this one. Good luck. Have fun with these things. You will get on a good roll with them. Like you'll get moving pretty darn quick with them. Slow down. Ones like this, where you have that negative variable, can throw a loop into it and mess you up. So slow down. Don't get going too fast and make easy mistakes. You know what? I just popped in my head. I am going to say one more thing. I'm going to try and do it in 30 seconds because it's a super long video already. Okay, I'll use this one as an example. Okay, I found what k is equal to. It's a negative 13. How do I know that beyond a shadow of a doubt? Well, let's actually double check it. So I restarted with this. I started with this equation. Negative 7 is equal to negative 20 subtract k. Well, let's just put negative 13 in for k. Let's see if it actually works. Negative 7 is equal to negative 20. Come on. Subtract. I'm putting in for k, negative 13. So I'll put that in right here. 13. Negative 13. Cool. Let's use our integer rules. Subtracting a negative is the same as adding a positive. Negative 20 drops. Negative 7 drops. Okay, I can simplify over here. Negative 20 plus 13. The difference there is negative 7. Equal sign drops down. Negative 7. Check it out. Negative 7 equals negative 7. It works. So I checked my answer. I proved that it's correct. We're rocking and rolling. Okay, you're going to have to do this in your guys' work as well. Check every single answer you do the exact same way. And don't forget, this is correct. Oops. Show off that's correct. Give it a messy check mark. Have fun.